infinity and beyond. Chapter 6, lesson number 9, the sum to infinity. So what is that all about? Well, let's think about this infinite geometric sequence. 1, 2, 4, 8, 16. We can see we are multiplying by 2 every single time. Let's say we want to take the sum of the first 5 terms. If you add up 1, add 2, add 4, add 8, add 16, you get 31. If you take the sum of, say, the first 10 terms, what do you get? Well, you end up getting 1023. And if you add together the first 20 terms, let's just go mental, you end up getting 1,048,575. What do you think happens if you add 21 terms and 22 or 50 terms together? Well, as you can see, this sum is just going to increase and increase and increase without a limit. However, if you think about this sequence here, we've got a half, then we've got a quarter, then we have an eighth, then we have 1/16. So we're going to be halving the previous term in order to get the next term. If you take the sum of the first 5 terms, you end up getting 0.9375. If you add together the first 10 terms, you end up getting 0.998, and so on. And if you kept on going and you added 11 terms, 12 terms, 13 terms, up to 20 terms, you end up getting 0.999 to 3 decimal places. Again, you could keep on adding another term, another term, another term. What do you think happens though if you do that? You are perfectly right. Really, the sum of the first n terms in this example approaches a limit of 1. So if you had 21 terms, then 22, you're going to keep getting 0.99999, then 0.999999999. It's just going to get closer and closer to 1 as n, the number of terms that you have, approaches infinity. What we say about that is that the geometric series, remember what you get when you add the terms of a sequence, the geometric series has a sum to infinity of 1, and we write that as capital S for sum, and then infinity, and that would equal 1. Really, how do you know if a series has a sum to infinity or not? Well, what tells you is the value of R, also known as your common ratio. That determines whether or not a geometric series has a sum to infinity. In other words, if it tends towards a limit. If R is between -1 and 1, then the geometric series has a sum to infinity. And it can be worked out using this formula. The formula is the sum to infinity equals A over 1 minus R. But remember, there is only a sum to infinity if R is between -1 and 1. Let's try some examples. So example 1, explain why the geometric series 27, add 18, add 12, add, and so on, has a sum to infinity, and find the value of this sum to infinity. So, first of all, we know what A is. We know A is just the starting value, and that is 27. So we can write down A equals 27. The ratio, we need that. What is our common ratio? Well, remember, to get the common ratio, what you can do is you can divide the second term by the first. So we can do 18 over 27. And if we simplify that, we end up getting Mark. Brilliant. We get 2/3. Perfect. So how do we know then that there is a sum to infinity? Brilliant. If you look at R, a sum to infinity exists if R is between -1 and 1. And in this case, well, 2/3 is less than 1 and it's bigger than -1. So the geometric series has a sum to infinity. Yeah. And find the value of the sum to infinity. How would you do that? Well, you would use this formula that's up here. So the sum to infinity equals, it's A over 1 take away R, and that would equal, replace A with 27 and replace R with 2/3. So we have 27 over 1 take away 2/3. Simplifying the bottom, 1 take away 2/3, Sarah, is brilliant. That's just 1/3, so it's 27 divided by 1/3. And that would give you, you can move the 3 up to the very top. So 27 times by 3, that would all be over 1, giving you just 81. Or you could think about it as 27 divided by with a wee divided sign, and then 1/3, flip the third upside down, change the divide to a times. Either way, you still get 81. So you can say then that the geometric series has a sum to infinity of 81. Woo! Example 2, U1, U2, U3. That is a geometric sequence with U1 equal to 48. And the sum of UK, going from k equals 1 all the way up to infinity, equals 64. Find the value of U4. So how would you start this one off? Well, right away they're telling us that U1 equals 48, meaning then that the value of A is 48. Woo! What we are also told is that the sum of UK going from k equals 1 up to infinity equals 64. So in other words, if you work out U1 plus U2, then U3, then U4, then U5, then you add on U6, then add U7. If you just keep adding all the terms all the way up to infinity, it's 64. In other words, the sum to infinity equals 64. So because we know this sum to infinity, we can rearrange that to work out this value of R. So we know the sum to infinity, we know A, we need to work out R. So we can say then, well, the sum to infinity equals A over 1 take away R. So A is 48, 1 take away R would just A is 1 take away R, and that would equal, well, the sum to infinity is 64. Multiply both sides by 1 take away R and we get 48 equals 64 bracket 1 take away R. Multiply out the brackets and we have on the right hand side 64 take away 64R. If we add 64R to both sides, we'd have 64R plus 48 equals 64. Then subtract 48 from both sides, and we would have 64R equals 16. Then divide both sides by 64, so R would equal 16 over 64. And if you simplify that, potato head, you would get, well done, you would get 1/4. Woo! So we know then the value of A, and we know the value of R, and we also know this sum to infinity. How would you work out a specific term? What would you do? Brilliant. You would use the formula that we learned a couple of lessons ago to work out a specific term in a geometric sequence. You use the formula UN equals AR to the n take 1. Yeah. So n is going to be 4. We're wanting U4, so U4 would equal AR to the power of 4 take away 1, which is 3. Replace A with 48 and replace R with 1/4. That will give us 48 times 1/4 to the power of 3. 1/4 cubed, well, if you cube 1, you just get 1. Cube 4, you get 64, so it's 48 times 1 over 64, and that would simplify to, go on Buzz, brilliant, 3/4. Yeah! That is the sum to infinity. Have a go at these questions, see how you get on in the booklet, Unit 2, page 30 and page 31. You're working out the sum to infinity. Best of luck. Woo! And beyond.